Okay, good. Today we will talk about nice chapter and easy chapter, which is about rotation. Basically, this chapter depends on previous chapters, such as chapter 5. We need just to convert the linear motion to the rotational motion, or translation motion to the rotational motion, and it is easy. Just you need to get used with the new parameters. For example, here in linear equation, if you remember, equation of motions, instead of v, we now use theta. Instead of x, instead of v, we use omega. Instead of x, we use theta. And instead of a, the acceleration, we use alpha, and etc. You need only just to practice and solve many problems to get rid of this new parameters. Okay, let's start. Actually, we will repeat chapter 3 and chapter 4 and chapter 5, but with the new notations. For example, here we have a wheel starts from rest. Which means omega 0. Instead of v0, we have omega 0 is equal to 0. And rotates with constant angular acceleration. Constant angular acceleration, which means we can use equation of motions about a fixed axis passing through its center. It completes the first revolution, which means delta theta 1 equal to 1 revolution. And this means it's equal to 2 by rad in 6 seconds, which means T1 equal to 6 seconds. After it starts, how long after it starts will the wheel complete the second revolution? He asked how long, which means we are looking for T2. How much? After second revolution, which means delta theta is equal to 2 revolutions, which is equal to 4 by rad. Okay, so since we are looking for T2, we can directly do the following. We can say delta theta 2 is equal to omega 0 T2 plus half alpha T squared. صحيح يا شباب؟
Yes.
Okay, now omega 0 is equal to 0, so we can ignore this term. And T2, this 2, if you rearrange, is equal to, this is 2 delta theta 2 over alpha under square root. But we don't have here alpha. We don't have the rotational acceleration. From where we can get it? Here we have another given for the first revolution. Using the first revolution information, we can similarly say delta theta 1 is equal to omega 0 T1 plus half alpha T1 squared. Here we don't have omega 0, it is 0. So alpha is equal to 2 delta theta 1 over T1 squared. We have all the parameters. 2 times delta theta 1 is equal to 2 by rad over T squared, which is 6 squared. If you calculate this one, can you calculate this one? How much does it?
0.34.
0.34. This one?
Yes.
Okay, rad per second square. Note here, instead of meter, we use rad, okay? Radian. Okay, now we have alpha, and since the alpha is constant, so it is usable here or there. So T2 should be equal square root of 2 times delta theta 2, which is 4 by rad over alpha, which is 0.34. طبعا الجميع تحت الجذر. How much this one?
8.48.
8.48 seconds, which is our answer. Clear يا شباب؟
Yes, clear.
تمام. What I want to say here, it is similar to chapter 3, exactly like in chapter 3 for this question. But what the only difference here that we use the rotational notation. Okay, here is another example.
Doctor,
Yes.
how did you get the first theta?
Which one? Okay, it's given. It's given. You mean this one?
Yes.
Okay. Here it said it completes the first revolutions. First revolution, which means we have only one revolution. So delta theta is equal 1 revolution. And 1 revolution, if you go back to your book or your teacher slides, you can say that 1 revolution equal 2 by rad.
Okay, thank you.
يعني هنا revolution, if you start from here and you come back here, this is 1 revolution. كم ثيتا هذه؟ من هنا 90 180 270 360. So 1 revolution equal 2 pi rad and equal to 360 degree. Clear?
Yes.
Okay,
Thank
good.
you.
Another example. Here we have a disk rotates at constant angular acceleration. Constant angular acceleration, which means we can use the equation of motion. Alpha is constant. Okay. From angular position theta 1, it's given 12 rad. To angular position theta 2, 27 rad. يعني like it says from x1 to x2 in 5 seconds. Here t is equal to 5. At theta 2, its angular velocity, which is omega 2, is equal to 14 rad. What is its angular acceleration? He looks for the angular acceleration. Okay, شباب? Here we have t, we have theta 1, we have theta 2, and we have omega 2. Okay, if you go to your formula sheet, since we have omega 2, we can use which equation? I think we can use this one. We can say theta 2 minus theta 1 equal to omega 2 t minus half alpha t squared. If you remember, we have another equation that's theta 2 minus theta 1 equal omega initial, omega 1 t plus 1/2 alpha t squared. Do you remember this one?
Yes.
Okay, since I have omega 2, so I'm going to use this one. Okay? So
Okay.
he looks for alpha, just substitute. We have 72 minus 12 equal to 14 times t is 5 seconds minus 1/2 alpha 5 squared. Just rearrange this one. You get alpha equal to هذه تصير هذه نجيبها على الطرف الثاني نضرب باثنين نقسم على 5/4. You will get 2 times. Okay, just a minute, please. Okay, we will have 72 minus 12. It is 60. Minus 14 times 5. I think it is 70. Okay.
Times 2.
times 2 over 5 squared. هنا في عندي minus صحيح؟
Yes.
Okay.
Another
How much is this
minus.
one?
Let me
Okay. هذا
calculate it.
ما ادري ليش كذا. كم تطلع هذه؟
0.8.
This is 0.8 rad over second square. Please correct me in math. Sometimes يعني مع السرعة.
It is correct, 0.8.
Okay.
A lot of these equations in chapter 10 are solved in the chapter 2 way, right?
Yeah, this is I think in chapter 2 and chapter 3 or chapter 3. I don't remember.
Like the
actually.
acceleration and whatever equations.
Yeah. Yes. Yes. This is exactly what we have, I think, in chapter 3 or chapter. Well, I don't remember.
It's either 2 or 3.
Yes.
But you get the idea.
Yes. But the only difference here that the notation, instead of A we have alpha, instead of X or R we have theta, and etc. Okay. Then we have something about rotational inertia. Rotational inertia here reflects, let's say, the mass. It's not the mass, but it reflects the mass. يعني, if you remember, for example, for kinetic energy, we used to have it's equal half mv squared. Now, in this chapter, the kinetic energy equal half. Instead of mass, we have to use the rotational inertia. هذا يسبب لي مشكلة مش عارف قصته. Okay. And instead of v, we use omega square. We use different notations. Only here we will use the notations. By the way, I put this slide just to remind you that I will be given in your exam in the formula sheet. It's either will be directly given like a number, or it's said, for example, in this example we're going to use solid cylinder, and in your formula sheet it's known that for your solid cylinder that rotates about center diameter, for example, center diameter, this one. Or if you have a thin rod about axis through center perpendicular to length, it will be this one.
So it will be mentioned in the question.
Yes, so you don't have to know it by heart.
That's good
Okay.
to know.
Here we will start another type of questions. It has some concept, but during the solving of this question, we will go through this concept. Here, a uniform sphere of radius 2 meters, it's given, and mass 3 kilograms rotates freely with constant angular speed. Constant angular speed, omega, is equal to 10 rad per second, and it is constant, which means alpha is equal to 0. If we, يعني this is and for your information, if we need it, يعني. About vertical axis that is tangent to an equatorial plane of the sphere, as shown in figure. Find the kinetic energy of the sphere. And here we have the sphere. It's rotate about this axis. It's fixed in this point with the axis, and it's rotate here. We need the kinetic energy. Okay. If you remember, we have kinetic energy is equal to half I omega squared. But here we don't have I. It's not given, but we have uniform sphere. Okay. For the uniform sphere, we has a uniform sphere. We know that I is equal to 2 over 5 mr squared. However, this is if the rotation in the center of this one. Center of mass. So here we use the parallel axis theorem. Do you know what is the parallel axis theorem? If you have here anybody, okay, and this is the center of mass or the axis rotation. This is the center of mass, and here is the axis rotation. Here, and the distance is h. I here should be equal I center of mass plus h m squared. Do you know this one?
No.
Okay. I will الآن assume the rotation axis this one. The answer will be like this. Half I, it is 2/5 mr squared omega squared وعلى طول نوجدها. However, the rotation is not here. The rotation is here. What should we do? It is far away from the center with distance h equal r. This is h equal r. So we use, this is not correct. We use k is equal to 1/2 I center of mass plus h m squared, oh sorry, mh squared. اوكي انا هنا السكويرد على الاتش. ايوه كيف نمحيها هذه؟ هذا غلبني الباوربوينت اخر مره رجعني. اوكي اتش سكويرد ام في اوميجا سكويرد. الان ايش الاي سنتر اوف ماس فور يونيفورم سفير؟ اتس لايك ذس 1/2 instead of I center of mass we use 2/5 m squared r squared. This is what we know. Plus here, what is the h? H is the distance from the rotational axis and center of mass, or center of mass, this axis. Okay, this is h here, which is r squared multiplied by m, so it is r squared omega squared. Clear شباب?
Why is the r squared?
Because how much h here from this point to this point?
It's 1h.
Yeah, it's equal the radius, right?
Yes.
So, and the radius is r.
Okay.
So, instead of h, we put r.
No, I'm asking why is it squared?
This is the formula.
So it will be given.
Yes, this is the formula اللي هي parallel axis theorem. خليني بس هذه ارتبها. اول مره استخدم الباوربوينت في هذا فمغلبني.
عادي.
Okay, this is the parallel axis theorem. Okay, let's substitute. It is 1/2 and 2/5. This is 5/5, so it will be 7/5 m r squared omega squared. صحيح? Or this we can be 7/10, which is equal to 7/10. Instead of m, it is 3. بعدين لا حول. Instead of m, we have 3 times. Instead of r squared, we have 2 squared, which is given. And instead of omega squared, we have 10 squared. If you calculate this one, how much is this one?
Let me calculate. 840 joules.
840 joules. You didn't study the axis parallel theorem?
No, not yet.
I don't think we reached it yet.
Okay. When will you finish this chapter?
I think we're about to finish chapter 10, but we didn't reach this yet. Okay. I think tomorrow we might finish it.
Okay. Just يعني let me spend 1 minute just to explain it. Okay? 1 minute only. Again, just to be
the I, is it gonna be given on each question or like a paper at the end, like the slide you showed us?
Either they give you I directly, or you give you the body that you use. For example, here we use uniform sphere, and from the formula sheet, the uniform sphere I is known for the uniform sphere, or it's mentioned directly in the question. Okay. In general, if I have, for example, let me go back here. For this this hoop, okay?
Okay.
If I want to find I for this hoop, since this rotate about its axis, it is I equal mr squared, okay? Clear?
Okay.
طيب لو instead of the axis of rotation, instead of its center, if you assume this is the rotational axis, يعني الهوب جاي هنا وبيدور كذا. clear.
اوكي فلازم نجيب السنتر اوف ماس حق الهوب
yes
ونزيد عليه المسافة.
بالضبط، تجيب السنتر هذه للمسافة هذه يسمونها h. This is called h, and so I becomes equal I center of mass, which is mr squared, plus m the mass h squared, and h is the distance between the original center, يعني center of center sorry, the rotation or the axis of center of mass and the rotational axis. This is h.
Is it always mh squared?
Yes, this is called axis parallel theorem or parallel axis theorem. Okay.
Okay.
Okay. This is
good
the idea in this question. يعني قلت لك if this the rotation, note here the rotation is at the edge. If the rotation at the center, no, we use only 2/5 mr squared without this term. Okay.
Okay.
Okay. طيب. Then did you study about the torque?
No.
Okay.
We didn't reach
Next
it.
time maybe I will do the.
We're quite late, I think.
Okay. Next time maybe I will shift the lecture to Sunday, for example.
Yeah, maybe later so we make sure that everyone finished it.
Okay. Okay. طيب. Please, can you make the attendance now? Take 1 minute to make attendance.
Is it counted because I did it in the beginning? The attendance.
No, if you did it, خلاص.
I think a lot of people didn't come today because they didn't finish chapter 10. That's why.
Okay. No problem. This chapter is important actually in the final, in the next exam. Okay.
What's the next exam material? Is it from the midterm, like from chapter 8 to chapter 11?
I think from chapter 9 to chapter 12. 9, 10, 11, 12, I think.
Okay.
No, I don't think it's 9, 10, 11.
9, 10, 11. Okay, without a 12. Okay. Okay. Now, next concept will be about the torque. And the torque, يا شباب, simply here, torque is equal R cross F. R, it is the distance between the force and the center of rotation. يعني for example, for this is R. احنا نسميها بالعربي ذراع القوة. القوة في ذراع القوة, which is equal to R F sine theta. Okay. For example, if you have this wrench, do you remember this wrench? هذا اللي كنا زمان في جرة الغاز فيه. Okay. If you apply a force here, F, so the torque will be equal R, which is this distance, cross F. For example, if you have long wrench or long R, T will be greater, so it will be easier to release the screw. And if you do it here, it will be harder. Similarly, if you go to open the door, if you open the door from end point, it will be easy. But if you try to open the door from the beginning, for example, this is the door. Okay, هذا الحائط here. If you close the door from here, it will be easy. But if you close it from this one, it will be harder. صحيح?
صح.
So this is the concept of the torque. Now, if the torque is clockwise, it will be negative. If it is counterclockwise, it will be positive. Clear? هذه راح تستخدمها من هنا لنهايه الشابتر، راح تفيدك بكثير امور. If the torque is clockwise مع عقارب الساعه it will be negative. If it is counterclockwise عكس عقارب الساعه it will be positive. Okay. Here in this question, find the net torque on the wheel in figure 5 about the axis through origin if A is 10 centimeter and B 25 centimeter. Here we have a wheel, okay? The diameter A is 10 centimeter and B is 25 centimeter. We apply 3 forces, this one and this one and this one. So the torque net equal to the torque due to 10 Newton plus torque due to 9 Newton plus torque due to 12 Newton. صحيح? We simply use this equation, and so we need to know R, we need to know F, we need to know theta. For the first one, 10 Newton, this is the center. كم ثيتا هنا؟ 90. كم R? How much the R?
25.
It's B.
25. B, 25. So it's equal to, instead of torque 10, I will say it is B, which is 25. I will do it in meter. I will convert it to meter because the answer in meter. So it is 0.25 times 10 Newton times sine 90, which is 1. صحيح؟
صح.
طيب, is it clockwise
It's
or
minus.
counterclockwise?
It's clockwise, so it's minus.
Excellent. هنا بنحط minus. Clear?
Clear.
Plus for the 9 Newton. هذه 9 نيوتن. هذا السنتر. كم الزاوية هذه؟ 90.
90.
So it will be, and what is the R here? R is B, which is 0.25 times 9 Newton, and theta 90, so it is time 1. And is it clockwise or counterclockwise?
It's clockwise, so it's minus.
So it is minus. Plus for the 12 Newton. Here خلينا نحدد أول شيء R. كم الR؟
الار 10 سنتيمتر 0.1
تمام.
متر.
كم الثيتا؟
30 degrees. لا
210 degrees.
مين عنده رقم ثاني؟ Another option. Actually this theta. So this is 90. هذه حط لك اياها. This is the trick in the exam. Some students will say this is for example 12 cosine 30 and etc. No, what we'll do, the force is applied here, right? And what is the angle between this point to the center? جنني القلم بعدين ما هو. Okay. From center to this point, with respect to the force, it is 90. Okay شباب؟
فنسوي
Okay.
calculations الحين عادي.
ايوه بس بعدين مع القلم هذا جنني. ما علينا. So it is the R is 10 centimeter 0.1 times F is 12 times the angle is still 90. We use 90, so sine theta is 1, and it is counterclockwise, so it is positive. Okay. Clear يا شباب؟
Clear.
فركز على هذه الزاوية. This is just to يعني
Trick.
it's a trick to trap you. So here يعني انت بنفسك بيدك اعملها روتيشن. هذه يعني كذا اعملها روتيشن لحد ما توصل النقطة هذه to this point. راح تلاقيها صارت لليسار. Okay, if you calculate this one كم يطلع الجواب يا شباب؟
minus 3.55.
Okay. minus 3.55 نيوتن متر. طبعا remember you have to convert this one. Okay. again, here instead of position X, we use theta. Instead of V, we use omega.
I'm sorry, doctor, but can I ask you something?
Yes, please.
Can you repeat the clockwise and counterclockwise for a brief second?
طيب. Okay, هذه from this point, if you pull the wheel in this direction, what's the direction of rotation?
Clockwise.
كذا صح؟
Okay, now I got it. Thank you.
Okay? يعني امسك الطرف اللي عليه القوة.
تمام.
Okay, instead of M, we use the rotational inertia. Instead of force, we use the torque. If instead الwork بالwork, just we convert it, okay? Kinetic energy, instead of half mv squared, will be half omega I omega squared, and etc. طيب. Now we back to chapter 5. However, here we don't say that neglect the pulley. We used to use massless pulley. هذه البولي هذه we say massless, but here it's not massless. Let's see what we will do in this type of questions. Now, here, a mass M1 is equal to 5 kilogram is connected by a light core to mass M2 4 kilogram, which slides on a frictionless surface as shown in figure 7. The pulley or the disc of radius 0.2 meter rotate about frictionless axis. If the magnitude of acceleration of M2 is 3.5, what is the moment of inertia of the pulley? هنا في عندك معطيات. M1 it's given, M2 is given, R of this pulley, this is the R. Okay.
Acceleration is given as well.
Yes. هذه ال R. Okay. And the acceleration is given, is equal to 3.5 meter per second square. And if you assume the acceleration in this direction, so this will be accelerate in this direction as well. We are looking for I for this pulley. Okay. Remember what we use in the chapter 5, we make free body diagram for the first block and second block. Here we will use it for the first block, second block, and the pulley. And remember, if the pulley rotates clockwise, so the total torque is minus. If it is counterclockwise, the total force is positive. تمام. Let's do the free body diagram. For particle 1, what is the forces affected on the particle 1? We have M1 G, we have T1. خلينا نعمل بس الفري بادي دياجرام اكبره على الجهه المقابله يا شباب. This is the free body diagram. I need to just يعني make هذه كبيره شوي. البولي. This is M2 and this is M1 and this is the pulley of radius R, and we agree that the acceleration in this direction is equal to 3.5 meter per second. So it will be rotating in this direction, which means clockwise, and torque is equal to minus, and we have the acceleration here in this direction. So the free body diagram will be as the following. For this one, we have M1A, we have T1, tension 1. For the second block, we have only T2. We don't have M2G and normal force. We don't need it because it's frictionless. And here we have T2 out from this pulley and T1 from this pulley. And remember, دائما التنشن يا اخوان طالع من الجسم. It's out of the body. So for the mass 1, we say F net for the first particle is equal to M1. هذا القلم يا اخوان جنني. اعوذ بالله من الشيطان الرجيم. المره الجايه خلاص بدي ارجع على المايكروسوفت هذا الوايت بورد. احبال. اوكي. is
انت كأنك تضغط شيء اذا جيت.
لا القلم ما في عليه شيء. اوكي M1 في الاكسلريشن right but the acceleration is down so if you what's the forces we have T1 minus M1G is equal to M1 minus A. Okay? Right?
Yes, yes.
Right.
Or we can say that the T1 is equal to M1G minus M1A. This is for T1. Let's go to the second particle, this one. The only force here, we have the tension to the right. So we can say F net for the second particle is equal to M2A. F net is T2 is equal to M2A. Am I right?
Yeah.
That's it. Actually, we have M2, we have the acceleration. So this, if you calculate this one, M2 is equal to 4 times the 3.5, which is equal to 14 Newton. And this one, we have M1, we have G, we have the acceleration. This equal to, I think, 31.5 Newton. Okay. Now, we have the pulley. What about the pulley? You remember in chapter 5 we stopped here, but now we have the pulley. For the pulley we have, instead of F net equal MI, we say that tau net, tension net, is equal to I alpha. Okay, Shabab? This is equal to I alpha. Now, tau net, how many forces we have? We have tension from this rod and tension from the other rod. And the rotation is clockwise, so it is negative. يعني, so, for the first rod, T1, we have, since the T is clockwise, it's minus T1R. صحيح؟ لاحظ انه this point لتحت صحيح؟
صح.
Tension. So if you pull in this direction, it will rotate clockwise.
T2 is positive.
Yes. And the theta here is equal to 90. So it is minus T1R plus this one, if you pull to the left, it will be rotate counterclockwise. So it is plus T2R and theta is equal to 90. Equal to I minus alpha. Why minus alpha? Because the rotation is, the total rotation is clockwise. صحيح يا شباب؟
صح لأن الاكسلريشن downwards.
Yes. Okay. Now, what I want to say that alpha, this one, طبعا minus I instead of alpha A over R. Why? مين يقول لي ليش؟
حولناه من circular motion إلى
Yes.
normal.
Yes. من translation motion, we know that the acceleration is equal to R times alpha. Okay? هذه you know this. هذه معلومة تعرفوها شباب ها؟
صح.
Okay
Yes.
شباب. What is the moment of inertia? We need I. Just rearrange. هذه تصير multiply by minus just to get rid of this minus and multiply by R and divide by the acceleration. So I will equal to T2R. No, T1R sorry minus T2R لأن ضربت في minus multiply by R divided by the acceleration. Am I correct?
Yes.
Okay. Now I have T1, which is 31.5 Newton. This is T1. This is T2. I have R. This is R. And I have the acceleration. Just substitute. You will get 31.5 multiplied by R, which is 0.2 minus 14 T2 multiplied by R 0.2 equal multiplied by 0.2 divided by 3.5. كم يطلع الإجابة يا شباب؟
0.2.
0.2.
So 0.2. Clear يا شباب? This is
Clear.
exactly chapter 5. However, here the body is not massless. It has mass. It has rotation. What's important in the body? Instead of saying F equal ma, we say tau is equal I alpha, and alpha is equal A over R, and I طبعا هنا أعطاني I directly يا شباب، قال لي وجد I. In other questions, you need to find what is I. It is mr squared, 2 over 5 mr squared, and etc. You know, you need to know the direction of rotation to know the sign. It is minus or positive. Okay. This question. A uniform solid sphere. This is solid sphere يا شباب. Of mass 5 kilogram and radius ½ meter is free to rotate about a horizontal axis passing through its center. يعني هنا في عندنا axis. Here we have axis, and it rotates about this axis. Okay. A string is wrapped around the sphere and is attached to an object of mass m. Here we have mass m. I don't know why they plotted in this way. And m is equal to 0.1 kilogram as shown in figure. Assume that the string does not slip on the sphere. Find the acceleration of mass. We need the acceleration. Here we have two bodies. We have the pulley or the sphere, and we have the mass. So what we will do is the free body diagram. What's the free body diagram? Here we have mg. Here we have the tension for the first particle. For the sphere, here we have only tension. صحيح?
Yes.
Okay. For the first particle, we say that طبعا the acceleration will be in this direction. It's given, so it is minus. We say that for the particle, F net is equal to ma. So tension minus mg is equal to m minus a. Just rearrange it. So tension is equal to mg minus ma. Now for the sphere, for the mass we know it from chapter 5. For the sphere, we have tau net is equal to I alpha. We have only tension. This is tension. Is it clockwise or counterclockwise?
Clockwise, so it's
So
negative.
it is minus. Minus tension R is equal to I minus alpha. Because tension is clockwise and total rotation is clockwise. Here, what I want to say that I for the uniform solid sphere is will be given. So this one is equal to, instead of I for the solid sphere, I think it is 2 over 5 mr squared alpha. Instead of alpha, I will put A over R. Okay. واضح يا شباب؟
Well,
يعني instead of I, just I put 2 over 5 mr squared because it's uniform solid sphere will be given in the write-up, in the formula sheet. And instead of alpha, we put A over R. Rearrange, just rearrange. R will goes with the squared, and we have R in the two sides. We can eliminate with this one. We can eliminate the minus this one with this one. So T will end up with T equal to 2 over 5 ma. Right?
yes. So you can
No.
multiply by 5 over 2m.
Yes. Now we are find the acceleration of mass, and we need A. Here tension and tension, they are the same. So we can say this one, equation 1 is equal to this 2. صح؟ فيصير عندك mg minus ma is equal to 2 over 5 ma. Just rearrange, you will get A is equal mg over 2 over 5 m plus small m. Now, small m is the mass of the small particle, this particle. Capital M is the mass of the solid sphere. اوكي يا شباب؟ عوض هذه 0.1 times 9.8 على 2 over 5 times capital M is 5 plus 0.1, and this will give me how much يا شباب؟
0.47.
0.46.
will give 0.46. في رقم بعد الستة هنا؟
Yes, 6.
Okay. meter per second square, which is our answer. Clear يا شباب؟
Clear.
Yes, clear.
هذا أخذتوه ولا بعد ما وصلتوا له؟
لا بشكل عام التورك ما بعد وصلنا له اللي هو تاو equals I alpha.
طب now you have a good idea about it?
Yes, indeed. Thank
Yes,
you.
of course.
Yes, good. Okay, here is where I have another question. Here is the disk or the sphere or whatever itself. It is another. It's a mass. يعني شوف هذا السؤال ايش يقول لك. A massless string is wound around a uniform disk. Here we have a uniform disk and there is a string. The disk is released from rest. From rest, which means omega initial is equal to 0 if we need it. Find the magnitude of the acceleration of the center of mass of the disk. We need the acceleration of center of mass of the disk, which means we need A, not alpha. Okay? لو قال لك what's the acceleration of the disk itself of rotation, we need alpha. But here we need A because we need the for the system. Okay? Okay. How many bodies here we have? We have only one body, which is the disk. But the disk is a mass. So we can assume it as two bodies, the disk itself and the mass itself. So we can do the free body diagram. We have mg and we have tension for the mass. So we say F net for the mass is equal to ma. So tension minus mg is equal m minus a, or tension is equal to mg minus ma. This is if we assume the disk as a mass. Now I will go to the rotational motion. Here I have tension. So tau net is equal to I alpha. We have, is this one clockwise or counterclockwise يا شباب?
Clockwise.
It is clockwise, so it's minus. So minus T R equal to rotation طبعا in this direction, so it is minus, so I minus alpha. Here we have uniform disk. For the uniform disk, minus, instead of I will put half m r square will be given. Instead of alpha, I will put a over r. Okay, again r with square will go صحيح؟ then r square على r تصفي r. R we have in two sides. I can eliminate this one with this one. I can eliminate minus with minus. I will end up with T is equal 1/2 ma. صحيح؟
Yes.
صح.
Now, since the tension is the same, I can say that mg minus ma is equal to half ma. I'm looking for a. يطلع عندي mg is equal to 3 over 2 ma. M will go, so the acceleration is equal 2 over 3 times g, which is 2 times 9.8 over 3. كم يطلع هذا يا شباب؟
$6.53. It's correct.
Okay, 6.53 meter per second square. Did you get the idea how to deal with the rotational motion?
Yes, we did.
We do chapter 5 first, and we go to the chapter
Yes.
10.
You say tau equal I alpha. but you need to know where is the direction to know the signs. Is it positive or negative؟ يعني it's similar. ما في ولا شيء يا شباب صعب. هذا الشابتر من أجمل الشباتر. If you understand chapter 5, so this one will be easy.
But again, to confirm, I will always be given, correct?
Either I given as a number, or it will be asked as I, or the يعني يعطيك الفورمولا حقت الاي.
تمام، مشكور.
Okay, this is a question. It's more complicated. Here we have two objects of mass m1 and m2, 1 kilo and 2 kilogram respectively, hang at the end of massless string that passes over a pulley of radius 10 centimeter. Remember, we need to convert it to meter. And moment of inertia I 0.01 kilogram meter squared as shown in figure. What is the magnitude of linear acceleration of the masses? We are looking for the A. Again, here we have free body diagram. For first one, we have M1G. We have tension 1. For the second one, we have M2G. And we have T2. For the pulley, here we have T2. And here we have T1. صحيح؟ دائما tension خارج يا شباب. Clear?
Clear.
Yes.
Now we will deal it as chapter 5. Start with the first block. We say that F net equal to M1A. طبعا كونها هذه 2 kilogram, this is 1 kilogram, I will assume that the acceleration will be in this direction, and for this one will be in the other direction. So the rotation will be in this direction. Okay? واضح شباب؟
Yes. واضح واضح.
تمام. So for T1 we have بعدين yes, we have tension 1 minus M1G is equal to
M1A.
M1A, or you can say that T1 is equal to M1A plus M1G. طيب نيجي ل T2. For T2 we say that T2 minus M2G equal to M2 minus A. ليش هنا minus?
Because it's going down.
Yep. So we say that T2 is equal to M2G minus M2A. Here we have M1, T1 and T2. Now for the pulley, how many forces affect the pulley? We have two forces, from tension 1 and tension 2. Remember, here I will put tau net is equal to I alpha. Okay, I will use the blue. Okay, T1, is it clockwise or counterclockwise?
Counterclockwise.
Count.
So it is positive. So T1 R. T2, is it clockwise or counterclockwise?
Counterclockwise.
Clockwise.
Clockwise, I mean.
Clockwise, أحسنت. So minus
T2R.
T2R is equal to I minus alpha. Why minus? Because we assume the rotation in this direction. And this equal to minus I, instead of alpha I will put A over R. طيب الآن we are looking for the acceleration. Where we have the acceleration. Okay, and I will substitute instead of T1 its value, and instead of T2 its value. So instead of T1 we will have M1 A صحيح plus M1G مضروبة في R، فبدي أدخل R على طول. R plus M1G R minus, instead of T2 I will put M2G times R plus M2A times R. This equal to minus I over R في ال A. صحيح؟
صح.
Yes.
Okay. Where is the terms with acceleration? We have this term,
This one, last one.
this one, and this one. Just I will يعني bring them together. I will put A عامل مشترك بتاخذها في M1 plus M2 في R plus I over R A will equal to M2 minus M1 this times GR يعني just it's a matter of math يعني بطلع هنا ال A عامل مشترك واقسم على هذه so A will equal to M2 minus M1 طبعا you can use your own method maybe you can use something simpler divided by M1 plus M2 R plus I over R. Everything is given. Here I is given as a number يا شباب 0.01. So we can directly substitute 2 minus 1 في 9.8 ضرب R 0.1 divided by 2 plus 1 في R which is 0.1 plus I it is 0.01 over R 0.1. How much is this one?
2.45. It's correct.
2.45 meter per second square. Clear يا شباب?
Clear.
Yes, clear.
Doctor,
Yes.
why did you say the alpha clockwise?
Okay. And here I assume this since M2 is 2 kilogram and M1 is 1 gram. Logically, which will fall down and which will go up? M2 or M1?
M2.
M2 راح تنزل لتحت صحيح؟
Yes.
M1 راح تطلع لفوق فبالتالي البول كيف راح تتحرك كذا ولا العكس؟
Okay, I got it.
Okay, good. Okay, the other concept is the power. You know, we know that the power from chapter, I don't know, 8 or 7, I don't know. Power is equal to work, for example, average power is equal, if you remember, work by delta T, or power equal, I think R dot V, I don't remember.
FV.
FV, yes. Here similarly, average power will be work by delta T, or instead of F, we put tension. Instead of V, we put omega. So power is equal to tau omega. Okay. Okay. Let's say an engine deliver powers. Here we have power is equal to 1.2 10 to power 5 watt. This is given. To rotate a disk with constant angular speed, omega constant, which means alpha is equal to 0 if we need it. If the work done by the engine in one revolution, لاحظ, one revolution, which means delta theta is equal 1 revolution, which is equal to 2 pi rad. This is the work, 3000 joule. Find the value of omega. كم الأوميجا. Okay. We can do it in many ways. For example, you can say, since omega is constant, we can say that omega اللي هي السرعة تساوي المسافة over t. Or you can say that delta theta is equal to omega t plus 1/2 alpha t squared. Since omega is constant, so alpha is equal to 0. So we will end up with the same, that angular velocity is equal to angular distance divided by time. But here we don't have the time. From where we can get the time? But we have the power and we have the work. And we know that the power is equal to work divided by time. So time here will be power over work, which is equal to 1.2 10 to 3, sorry, 10 to 5 على 3000 and this is equal how much شباب؟
40.
0.025
Wait,
seconds.
how did
صحيح؟
you get power over
Okay, we know that the power
It should
is
be
equal.
it should
Work
be
over
work over power, shouldn't it?
more over.
Yes. اوكي انا سوري يا شباب.
It's okay.
سوري.
Second.
جل ما لا يسمع. Okay, so T is equal to work divided by power, which is equal to 3000 over 1.2 10 to the power 5, and this is equal 0.025. Am I right?
Yes, correct.
Second. So just substitute this amount here. So omega, طبعا distinguish between omega and W شباب, is equal to delta theta, it is 2 pi over 0.025, and this gives how much شباب?
251.3.
251.3 rad per second. Clear? يعني it is similar to what we had previously يا شباب, بس اللهم انه في عندنا some rotations we can use it. And for this rotation, يعني to get rid of this notation, just solve as much as you can. Again يا شباب, if you did not do the attendance, please do the attendance. Okay شباب, here we have 32 kilogram wheel, essentially thin hoop. لاحظ قال لي thin hoop, بالتالي I know what is I for thin hoop. I is equal to mr squared will be given, okay, if I need it. Of radius, this is r, 1.2 meter, is rotating about its axis at 280 revolution per minute. This is the omega 280 revolution per minute. شوف, remember this is revolution per minute, and usually we are dealing with rad per second. How can we convert it? We can say it is equal to 280 times, instead of revolution we put 2 pi, because one revolution is equal to 2 pi, divide by 1 minute times 60 seconds. صحيح شباب?
Yes.
And this will give me some answer with rad per second. Okay, we will calculate it later. Okay, it must be brought to a stop. يعني هذه omega initial, so omega final is equal to 0 in 15 seconds, which means delta time, delta t is equal to 15 seconds. What is the magnitude of the required average power to stop it? And I know that the average power B average, طبعا remember هنا هو طالب الماgnitude, فلو طلع معك شيء سالب don't worry, okay? B average is equal to work over delta t. But here I don't have work, I have delta t. But I have the mass or the inertia, and we have the velocity. And remember, work is equal to delta k, right? And this is equal to k final minus k initial, which is equal to half I omega final squared minus half I omega initial squared. Am I correct?
Yes.
Okay, omega final is equal to 0, so this one is equal to 0. So work is equal to minus 1/2 I omega squared, and I is given, so it is half. Instead of I will put m r squared omega initial squared. This is the work. So we are looking for the power. So the power average is equal to half m r squared omega I squared على delta t. This is equal to half. Instead of m, it is 32. Instead of r squared, I will put 1.2 squared. Instead of omega squared, I will put, okay, how much this number يا شباب؟ الفوق هذا كم؟
29.3.
Sure. Okay, it is 28 over 3 pi and squared over delta t 15. Now, can you calculate this one? Okay, here we have minus, شباب, because this one is minus. But we need, okay, I will. Can you calculate this one?
Yes, just a second, please. $1,320.57.
This one?
Yes, point
Okay,
57.
0.57. Okay, watt. Or it is equal to 1.3 to 10 to power 3 watt. اوكي في عندنا ماينس. طب هنا الاجابات ما فيش ماينس. Here it says what is the magnitude. So if you take the average, you will remove this one, you will remove this one. Okay, مش the average, عفوا ال absolute value, because it looks for, we look for the magnitude. Okay شباب?
Yes.
Okay. And thank you يا شباب. أنا يعني I hope you get something, especially that you did not study the talk. حسيتوا نفسكم شباب فهمتوا شيء علي؟
Yes, a lot. Thank you.
طيب شباب، ممتاز ممتاز. يلا جزاكم الله خير. See you next time إن شاء الله. And next time maybe I will make it maybe on Sunday to be sure that you proceed in the chapter. Okay?
Okay.
You will send an email anyway, right? As always.
I will send invitation. Yes, like this
Yes,
one.
sir. Yeah.
Okay. And I will ask people in the department or in the student success center to remind you. I will ask them to remind you. Okay?
Okay.
Thank you.
طيب so I will upload this PowerPoint presentation إن شاء الله on the team.
Okay. الله يعطيك العافية، ما قصرت.
الله يعافيكم ونشوفكم على خير. السلام عليكم.